Hello, everyone. Thanks for joining us tonight. This is yet another London Gophers online. Hope you'll enjoy the night. We have two amazing speakers tonight, and as always, let's start. So, first of all, thanks to our sponsors again. Even during these troubled times, we have companies that support us, support our community. Tyke, JFrog, and GoBridge, and more to come. For tonight, this is the agenda. Again, we have two speakers tonight. Shubham, that will talk about CLI in Go with Cobra. We'll have our usual break, 10-minute break, where we will have the break Conundrum that you're now familiar with. And then we have Shamala that will tell us about a log monitoring system in Go. So again, we are, as always, we welcome speakers at this point more than ever from all over the world. We're not like bound to the London boundaries anymore. So if you feel like you have something you want to share with our community, reach out to us. We're open for lightning talks, which are about 10 minutes. Or regular talks, which are about 30 minutes. And as always, we can help with refining your topic, giving you advice if you want to practice, and so on. And again, also if you want to help mentoring or supporting other people, just reach out to us, and we will try to put you in touch with someone who might need help. Just to give you some ideas, these are some talks that you might be interested in talking about. These slides will be shared later on, so you will be able to go through those in your own time. At this point, with no further ado, I will hand over to Shubham, who is going to give us this talk about CLI in Go with Cobra. Interestingly enough, it's quite late there, and I really appreciate his time. So thank you, Shubham, and I hand over to you for your talk.
Thank you, Antonio. Antonio, can you just confirm if you can see my screen?
Yes, I can see your screen.
Okay. So hello everyone, good evening, and thank you London Gophers to give me this opportunity to give a session on the CLI in Golang. So yeah, so it is basically we are just creating a CLI in Golang using the Cobra library in this session. So I will just give you a brief introduction of how easy it is to create a CLI in Golang with Cobra. So before that, I am Shubham Chadokar. I am a software engineer with around 4 years of experience in software development, and I majorly work in the backend technologies like Golang, Node.js, Docker, these things. And in my free time, I write articles and tutorials on Golang and GCP. So yeah, that's from my side. Yeah, so about this session, I will just give first, everyone knows the CLI, so it will be just a brief on CLIs, what is a CLI, and how it can make your life so easy. Then intro of Cobra library, and then comes the fun part, demo of CLI in Golang. So first so what is a CLI? So it is a command line interface. So it is a standard interface to interact with computer. So yeah, so just consider the command line interface is just like a medium to talk to the computer, or just passing whatever you want to the computer. So suppose whenever you see a command line, so for example, if you are on Windows, you can open the CMD, so that is a command line. So for Linux and Mac OS, terminal is the command line. So whenever we pass any arguments, or whenever we pass any commands, so what it just do, it takes those commands, give it to the computer or the program, then it runs and return that particular output to the CLI, and from there we get the output. So it's just a bridge between us and the computer. So why we are using it? So it's very simple. It is very lightweight and fast. It has minimal or almost no dependencies. It's a kind of mm, platform independent. So if you have created any CLI, so you can build that particular CLI for almost every OS, like for Windows, Linux, and Mac OS. And then this is very best for system administration and task-based automation. For example, suppose renaming all the files. So suppose you have around 100 files in your one folder, and you just want to rename it like that. That you just want to add a index 1, 2, 3 kind of thing, or prefix it with some particular ID. So in that scenario, if you go by the manual approach, it will be a very tedious job, and there is a possibility that you will mess up. So at that time you can create these kind of CLIs to automate the regular day-to-day job or repeating jobs. So at that time, CLIs are really great. So creating a CLI is not new to you. Yeah. So it's not that if you have never created a CLI, means you have created many CLIs. I think it just you don't know that those were the CLIs. So if you have written any time the C language code, so suppose even a hello world kind of thing. So that time also, if you remember the process, it's just like first we compile the program, then we build the executable. So that executable is a CLI because we are giving it a command to interact with our program, and then that program gives us the output. So it's just like a command line interface, but we just don't know. We were calling it a executable. So all the executables are kind of CLIs. Then if you are uh, if you have ever built any Golang binaries using go build or go install, so that those executables are also kind of CLIs because we are providing some inputs to it, and then it is taking those commands, talking to our code and giving back us the output. So that is also a CLI. So that's so whenever you say that have you ever created a CLI? Yes, you have created. So now the question is not about how to create a CLI, it's about how to create a CLI more efficiently. Like in the one CLI, you can do many jobs. It should be smart enough, like to do the conditional operation, and it should be very easy to create it. So these are the few things which needs to be tackled whenever we are creating a CLI. So yeah, so for the next slide, it is who are using the CLIs. Almost every product which we use or every language which we use are using the CLIs, like the Golang, Node.js, Python. So if you are in Golang development, and if you have ever run this Hello World program, so what we do, we run this go run main.go, so the file name. So that go command is a CLI which is taking the command run and the main.go as an argument. So it is just to then translate, means it's just then executing that file and then returning us the output. So that is also a CLI. Then if you are in Node.js or Python, so Node index.js, or so that time Node is a CLI. So in the same way, the Docker, Kubernetes, AWS, Azure, GCP. So all these platforms has their own CLI because CLIs are very fast and it is don't require that kind of dependencies. Yeah, so it is just basic examples, like maybe you are got a question like why we are using CLI, because it's 21st century. We have lots of fancy UI frameworks like React, Angular, Vue.js. So we can go for the UI. So we have to understand the basic functionalities of it, like how uh, tedious job it is to create a UI application compared to the CLI. So it's just like there can be many layers, but these are the basic ones, like your function code or your business logic. Then you have the APIs and server to serve them, and then you have your UI. So we have around 3 layers to taken care, and this UI is not an easy task because sometimes you will just spend some hours on to just to manage the grid and all those things. But at the same time, with the CLI, we just have to take care of our business logic, and then we just have to wrap it around the CLIs. So it is that simple. So if you just want to try after this session, you can, I'm sure that after this session, you will able to create your own CLI. So you can just create a calculator kind of the CLI. So try this to create in the UI part and then try to create in the CLI part. So you will get a very good description, or means very good idea like how easy it is to, means how feasible CLIs are. So we have many CLI options available, like these are the libraries which we can use to create the CLI. So these library, what they do actually, they just create a scaffolding of a CLIs or a basic CLI, so that you can, instead of wasting your time like means managing the code or managing the commands, you can directly use these CLIs to create a basic scaffolding. So there are two options. One is the UR-Fave dash slash CLI. So it has around 8K or 9K GitHub stars. So it is good. Then we have the Cobra CLI. So it has around 13 or 14K plus GitHub stars. So I'm not here to just tell you which is better and all. Both are really good. But I have personally liked the Cobra because it's compared to your Fave CLI, I found it much simple and easy to go. So what is Cobra? So it is just a library. So it is used as a base CLI to create new CLIs. So so who are using this Cobra library? So if you know the Hugo static site generator, which is written in Golang, so they are using their CLI, means they have created their CLI in Cobra. Then the Kubernetes, then the GitHub CLI also build their CLIs in Cobra. Then we have Docker, and there are many more. So you can go to their website, so their GitHub pages, and you can check like who has created the CLIs using the Cobra library. So Cobra concepts are very simple. It's just like forming the basic English sentences. Okay, so we have the three structural things, or the three concepts we can say, like commands, arguments, and flags. So commands are actions, like you are saying like you want to do this particular thing. Then we have the arguments. We can say like it is things like we want to do these particular actions on these things. Then we have flags, or you can say like it is a condition. Like if this particular flag is there, then do this action uh, in this way. Or if you have that flag, then do this particular action in that way. So it's just like a condition, or you can consider it as a if-else statement. So yeah, so the basic structure is like the app name. So sorry, yeah. So the basic structure is like the app name or your CLI name. Then you will give your the command. Then you pass the arguments, and in the end, you provide the flags. So suppose, for example, if you have ever uh, use any other third-party package in the Golang, so you might have used this. So there's gocat -u github.com. So what it is? So Go is a CLI, okay, your app name, get is the command, okay, and argument and flags are interchangeable, so you can use either way. Then the dash u and the github.com. So this is the this will it will take it as an argument. Okay, so now the fun part. So we'll start with a demo. Okay. So in this demo, first I will just tell you how we can add commands and subcommands, and how to read the arguments whatever we have passed. And in the end, we will see how to add the flags. And in the last, I have already created one calculator CLI, so I will just show you a demo. How it works, because if I just try to create that here, it will take some time. Okay. Okay, so to get started, first we have to install the Cobra library. So I already installed it, and after that we will initialize the Cobra library, or we can say we will create a scaffolding. Yeah, so our scaffolding has created. So we have only very basic things, like it has created one main.go. So as our all application in Go start with main, this also start with main. So what it is doing, it is just in the command folder, it is just executing one, or it is just calling one execute command. Okay, so all our content or all our commands will go under this CMD folder. It's the command folder. So here we have one root.go, which is our root command. So every CLI has its own root command, and then comes all the other commands. So we can call them as child commands, or the parent and then their child commands. It's just like a branching. So, so before we'll start jumping on the basics of it, let me give you a walkthrough of how it is working. So from main.go, first it is coming to the executable file. Okay, this command. And before that, it is calling this init function. Okay, so as our uh, all our Go application run the init function, it's just like a constructor. So what it is doing, it is calling first the cobra.onInitialize function. Okay, so this onInitialize function is an array of functions. So whatever functions we will pass in it, so whenever this CLI will run, it will first execute all these functions, and then only after it will execute the other function. Okay, so in the cobra.onInitialize, we are passing the init config function, this function. Okay, so here this particular function, what it is doing, it is just trying to read any configuration file if it is there. So you can consider it as a configuration file or environment variable file. So to read that environment variable file, Cobra is using another library called Viper. So Viper is heavily used for the reading the configuration files. So it is almost in any format you can pass, like the .yaml, .toml, .json, anything, and it will read it. Okay. So after that, once it will uh, initialize whatever function it has passed, it will go to this particular thing. Okay, so this is a struct of a command type, Cobra command type. So in this, we can give there are many other arguments which you can pass, like use, aliases, and these things. But these are you can explore. Uh, so for the basic commands are these use. So it just said that what is our uh, CLI name is. So we have named our CLI as a alpha. Okay. Then in the short description, you can pass a simple summary of your CLI, like okay. And in the long description, as it said, we just provide a long description of that particular CLI. Okay. Then we have one more last command is this run. Like whenever this root command will run, what it has to do. So, so whenever we'll run this root command, it will run this particular function. So whatever we have passed, it will run it. So suppose we have passed simple. Okay. So once you have done your coding in the CLI, you have to build it. Then only you can use that alpha keyword. So for that, you just have to do the go install alpha. Okay, and see. So it has created the means this particular command line function. This particular CLI needs. How can I put in words? It's just like if you want to run that alpha command directly, your go root and go path must be set in your environment variables, because whatever CLI we will create from Golang, these CLI will go directly inside the uh, go path and in go path's binary bin folder. So from there, that's why we are able to directly run it like the. So if you have seen, like it is just said hello London Gophers, whatever we have passed it here. Here it is. Okay, so as just a recap, so whenever this CLI runs, it first execute the command dot execute, then it comes here. Okay, so, but before running this particular function, it first execute all the init functions. Okay, so in the first command, we are just pushing all the functions which needs to be run every time. So it is just pushing the init config. So in this init config, it is just searching for a configuration file. Okay. And if that configuration file is there or not, it is just loading it. And after that, it is coming to this root command dot execute here. And then it is just ran this. Okay. Like a hello London Gophers. So now we know the flow of it. Let's add some commands in it and check. So to add a new command, it's very easy. We just have to pass Cobra add, and you can just say like command one. Okay, and that's it. So now if you can see, it has created one command one dot go file inside the command. So its structure is also the same compared to the Go. The only thing you will find here is this. In the init function, if you can see, it is saying like root command dot add command, and then it is just adding this command one command of command type. Okay, so what it is saying, it's just like if you just imagine a tree. So this is a root command. Then it has added one another command called command one. So to call this command one, what we have to do, we have to first provide the root command, which is our alpha, the CLI name, and then the command one thing. So let's check. So whenever you make any changes, you have to again build it. See, so now it says like command one call. Okay. So in this way, we can create as many commands as we want, but by default, it always create these commands to the root command. So what if you want to add a command to this command one, or call as like a sub command? Okay. So for that also, it is very easy. Just go to the Cobra, add, then we have to just pass the parent. This like who will be the parent of this particular command. Otherwise, by default, it is root command. So you just have to pass this parent, and then the parent will be the command one, and you also have to add this capital CMD, because this is the name. This is the variable name it has created while creating this particular command. So it always append this CMD to all the commands whatever you have created. Then you can just give like sub command or sub of one. Okay. So let's see the sub one. So yeah, it has again created a file in the command folder. And inside that, now if you see, it is adding this sub one command in the command one instead of root command. So if I just show you, yeah, if you can see, so by default it always use the root command, but as we have given the parent, so it's now using the command one as its parent. So let's try to build it. So if we just run the command one, so it is just returning the uh, command one call. Now that sub command is the child of the command one, so we can directly just have to pass like this sub one, and you can see like the sub one command is called. So it is very easy to create a tree of commands in it, like whatever commands you have to pass, you just have to write a proper structure. It's just like a hierarchy, like every time the root command will call, and after that, whatever command you have passed, it will call that, and in the same way, it will just go on. So as we now have understanding of how to pass the commands, so it's time to, so now we have completed the commands thing. It's just like that we have know how to create the actions. Now on what we have to do the actions, like the things. So, so to pass the arguments, it is very simple. Okay. So, so if you just see this particular structure, okay. So what it is taking one command of cobra.commands as a pointer, and the other thing is the arguments, the array of strings. So we have to understand that whatever arguments we have we pass, it always takes the string. Okay. If you want, you can just go and check its run. So it only takes the string. It don't have other types like the int 32 or the float and all those things. So now it becomes your responsibility to handle those commands properly. So whatever commands you will, whatever arguments you will get from here, you have to first convert them in a respective format. Suppose if you are handling, if you want to do some uh, operations on the integers, then you have to first convert that string into an integer and then do the operation. Otherwise, it by default it always takes these strings. So just let's add it. Okay. So yeah. So again, we have to just build it. come on. See, so it has returned like a array of, it is a string, like how 1 2 are. Okay, so now it becomes your responsibility uh, to manage these arguments properly. Okay, so this is a very straightforward things, like passing the command, passing the arguments, and then handling that. But in CLI, we also have these flags, which gives us the privileges to do certain kind of action on the same command. Like it's just like a if-else conditions or like a switch statements, you can say. So for that, we have two kind of flags. So uh, one flag is called persistent flags. So these flags are global. So suppose if you have created a flag in the parent level, then that particular flag is available for all the child classes also, or the all the child commands also. Sorry for that. Then we have the local flags, which we just call the flags. So that particular flag is a kind of local to that particular command. You will not find it for others. Okay, so before going ahead, I want to show you another great thing about the Cobra. Uh, so as you, whenever you create any CLI, you also want to document it, isn't it? So that the other person or the other user can able to use that. So if you know, like if you use any CLIs, like suppose our go command also, what we do whenever we stuck, we use the go help to see what are the commands available and what they do and all those things. So in the same way, Cobra also provide the same thing. Like we don't have to do this manually. So whenever we create any command, it just add those things. So for your example, just like alpha dash dash help. So see, so it first gives the complete long summary, whatever we have created in this thing. Okay, in the root command, and after that whatever commands are available for this root command, means the root CLI. So there is only one command, like command one. Okay, uh, so we don't have a edited summary, and after that these are the flags available for this particular root command. Okay, so now if you just want to see the available commands and have flags for command one. So in the same way we can do this. See, so the available command is sub1. Okay, and available flag is only help. So that's why I said, like, it is very easy to create CLIs in Cobra, because Cobra do lots of heavy lifting for us, instead of we have to take care of these minor things. These are very important, but many times we are we can skip these things. So now it's time to add the flags, which is like a conditions. So for that, let's come into the command one. Okay, so to add a global flag, what we have to just do, the command one command dot persistent flags. Okay, then you will get a set of flag of type. Like you can create a boolean type, or you can create a integer type, float type. So these are the flags. And so all these flags also have their own type. So according to your need, you can create it. So for our demo purpose, I'm just using the boolean, the bool thing. So if you see, we have two options. One is bool and the another one is the bool p. Okay, so both are same. It just there is only one minor difference. Like bool, this bool command don't take any shorthand notation of your flag. Okay, while the bool p takes the shorthand. So what does that mean? So if you can see that these flags as these things. Okay, so this is the longer version. Like you have to provide the complete spelling like dash dash help, or you can use the shorthand method like dash h. So to use the shorthand, you have to use the bool capital P, or if you don't want to use the shorthand, you can just go for the bool. So let's go to the bool. Uh, then the flag name. So suppose it's global. Okay. The shorthand will be the dash G. The default value we have to pass as it is a boolean. So suppose I'm just passing the false, or just like a global flag at comma. Okay. So in the same way, we can create the local flags. So to create a local flag, we just have to provide the flags. So all the options are available for this also, like boolean, integer, float. So again, we are just using the boolean p local dash. So here we had just defined the flags, but whenever we'll pass any arguments, how we are going to use it, so that we have to handle here. Okay, so for that you can say like global flag. Okay, so what it is doing, it is taking the command of the Cobra command, and then we are just using the persistent flag for the global values, then the get bool and the key type or the key value. It is the global. Okay, then you just have to handle it. So before that, let's define the local flag also. Just use that. Okay, so as we have now just defined our flags, so let's just build it so that we can see the changes. Okay. Yeah, so we don't have to provide the dash. It only takes one character. Yeah. So now if you can see in the command one help, now we have two extra flags. One is the global Okay, and another one is the local. Okay, so to just use them, we can just do like this, just pass like this G. So you can see like global flag called in command one, and for local you can see, yeah, local flag called in command. So how you can use these flags is just like right now I just pass it's displayed a print message. But to handle it, you can just call whenever this particular flag is on, you can call another function or some function A, and whenever this local flag called, you can call that function B. So in that way, for the same command, you can now handle multiple conditions. So that's very easy. Instead of creating tens of commands of same type, you can just give this flags and handle the multiple conditions. Okay. So now, as we have come, yeah, so we have covered all these things like add commands, sub commands, read the arguments, and adding the flags. So these are the basics of any CLI, which you will use in majority of times. Means these are the basics actually. So after this, whatever you do, you will do in your Golang side, like how to handle those arguments properly and how to deal with certain kind of scenarios. So those things you can use, means you can handle from your Golang side, and using these commands, subcommands, and flags combination, you can do lots of things with the same set of information or same set of rules. Okay, so I have created one CLI for this demo. It's like a calculator. Okay, so yeah, so this is the basic Kelsey mm, Kelsey CLI. So in that, what I have done, I have just added three commands. One is add. Okay. So if you can see in the add command, I have used one flag called float. Okay. So, and if that float is true, then I'm calling the add float. Otherwise, I'm calling the add int. So let's see this. Yeah. So as I discussed earlier, like it takes only the strings. So first we have to convert those particular string into the respective type, and then we can do the operation. So for add integer, it is just first converting it into the integer using the string con package. Okay, and then it is just doing the sum of it, and then just printing the message. In the same way for the float values, it is first converting that string into the float 64, and then it is just showing the uh, output. And then I have two subcommands. One is the even. So as its name suggests, it's just adding the even numbers, and then we have the odd. So it is adding just the odd numbers. That's it. So let's see. So this add command is available. Okay. So I can see add 1, 2, 3, 4. Yeah. So you can see like it has added uh, till 10. Okay. So what happens if I just
Quick
yeah.
question: is this then available online? Right? Is this code?
Yeah. So I have
Yeah.
after this slide, I have put the reference also.
Cool, perfect. Because we're running a bit out of time, so maybe if that's available, people might just go and explore the code by themselves.
Yeah. So yeah, I just need another 2 minutes. It is
Okay.
completed.
Cool, thank you.
Yeah. So in the same way, if you just pass the flow, so if you can see that it just says that invalid syntax. So what it is trying to do, it is trying to convert the string into the float. So the same way, if you just pass the flag, so see, it is 10.00. So yeah, so that's it from the demo side. Yeah, so for the practice ideas, you can create a ASCII CLIs, like whatever character you are passing, it will return you the ASCII value of that. A color mapper CLI, like you provide the hex code and it will return the color name. A file format CLI, with which we can convert the file format like from Word to PDF, and the same for the zip. So for the references, this slide is available here. Means the link is here. I think Antonio will give a proper reference of it. I will share with him. After that, this is the Cobra CLI GitHub, so you should go there and read the README. It is very well written, and you can see it. Then actually for this Kelsey CLI, I have already created one tutorial, so you can check it. So whatever I have run just. Then I have created two CLIs like my Kelsey and the color CLI, so which we just talked. So yeah, so if you have any questions, you can contact me using the mail, Twitter, or the GitHub. Yeah, thank you. Thank you for listening.
Amazing. Thank you very much. It was really a good talk. And I definitely have a couple of questions that, in the interest of time, I will keep them for a separate, message maybe on the London channel.
Yes.
And now go back to share my screen with the slides. Hopefully everyone can see them. So thank you again. And now let's move on to London Gophers in numbers. Everyone knows that we are, everyone is already, following us on Twitter. You probably have signed up on our meetup page. As I just mentioned, we are active on the London channel on Slack, on the Gopher Slack, and there you can find invite link. And most of us is following right now us on YouTube, which is a great way to reach out to everyone. Also, we have, as mentioned in the previous events, we have a London Gopher study group, which is led by Beth, one of our co-organizers. There is a dedicated channel for the London study group, which is the one you see there. The purpose is working together on the Go programming language book and the exercises that are on that book as well. As tradition, we have our JetBrains raffle. So if you go to that URL, gophers.london/raffle, and it will ask you for a code, and you can type in halfway. That's the code for this month. And this will put you into this raffle for 3 licenses for any product from JetBrains. Ideally, you might want to try Golang, but also you could use it for IntelliJ Ultimate Edition. As I mentioned at the very beginning, we also have, we are sponsored by JFrog, and JFrog is giving out some t-shirts with a nice gopher there. So you can use that QR code or just follow the link at the bottom of this page to enter the raffle from JFrog to get your t-shirt. Moving on, we have our break conundrum. This one, of course, as usual, we will leave it here for about 10 minutes and you can take a look. The question is at the end of this page, we'll say this code prints true or false values for 1, 2, 3, and 4. So for those, 4 lines. What are the values for 1, 2, 3, and 4, and why? And we're particularly interested in the why as well. So I'm going to now leave it here. So now in London is 5 to 8. So I think we're gonna be back in at most 10 minutes. So take this time if you need like a quick break, and then we will be back with the solution of the break conundrum, and of course our next speaker, and we really look forward to. Oh, sorry, we really look forward to it. So see you back in 10 minutes.
So
Hello, everyone. Hope you had some time to do what you needed to do, and now we are back and back with our conundrum. As you can see here, we have the previous slide, no solution for now. I will now hand over to Beth, who's going to guide us through the solution. I asked on YouTube to our attendees to give us some answers, and I see a person gave their own, ideas. So we're gonna now with Beth go through the solution and see if that's correct. Beth.
Yeah, hi everybody, and yeah, there's been some correct answers on YouTube. So this one is it's quite a straightforward one, but it underlines an important point in Go. So if we go to the next slide, please. And build some suspense as usual. So the code here prints 1 true, 2 true, 3 true, 4 false. So obviously there's something going on here. Next slide, please. So why is this false? Because it's actually nil. If we look through the code, there is 2 nil assignments, but this one isn't. So if you go to the next slide. Because this is nil here, so why isn't it nil when we get it back? Next slide again. So the trick to this, it's, as I say, it's quite a straightforward thing, but an important thing, that it's based upon the idea that an interface is only considered nil, i.e. the kind of null type or the no value type, if it's not associated with an underlying value. So that makes sense when we say a variable of x is 1, but this it counts even when it's a nil value as well. So if you look at error1 function, that creates a new variable of type error, and the nil type, or the kind of 0 type for that one, the default type is a nil. When we create error2, we're actually creating a pointer to an error, to an error struct in this case. So if we go to the next slide. So getting back to this code, yeah, we're going back to the code. You can see in the main function, when we assign E2 as error2, we're actually assigning a pointer. So while E2 looks a bit nil-ish, it's actually not nil because it's a pointer, whereas E1 is a value of the error type or the nil type. So this one, yeah, it looks, it was maybe quite an obvious one, but it looks like we're trying to suggest that all of them are going to be nil, but of course one isn't, because it's backed by a pointer type. It's pointing to a pointer, even though that pointer is nil.
Amazing, thank you, Beth, and thanks our attendees who played with us and gave us some answers. And now let's move on to the next slide. So again, just a reminder, raffle is open until the end of the meetup. So Gophers.London/raffle, code halfway, and you can get one of the JetBrains licenses. And as mentioned before, if you go to the link at the bottom of this slide, you can win a JFrog t-shirt. And now we can move on to the next talk of the evening, next and last talk of the evening by Shamala, which is lean log monitoring system in Go. I'm going to now stop sharing here and hand over to Shamala for her talk. Shamala, I think you're on mute.
Hi, can you hear me?
Yes, thank you.
Cool. Yeah, good evening, everyone. So I'm Shamla. I'm currently working as an SRE at Volkswagen Digital Lab Berlin. I'm working in tech for almost a decade now. Love being part of communities and speaking at meetups in general. I thank today the organizers for providing me with the opportunity to speak at London Gophers. So what I'm going to share with you today is my experience from a couple of years back when our platform was still young, and how Go helped us build a solution quickly that fit our needs. So the solution is basically a very lean log monitoring system written in Go. So there was an issue that was the login is slow. So from time to time, a team received complaints about slow login. So though they were well within their error budget and everything, like, it was not like 90% of the users were complaining about the login is slow, but there were some users from time to time complaining about login is slow, and the team wanted to get to the bottom of it. But again, how does one simply fix it slow? Here I actually wanted to put the meme of Sean Bean from The Lord of the Rings, but I'm an Indian residing in Germany giving a talk at London Gophers, so could not figure out the copyright issues of the meme. So imagine the meme with the text. One does not simply fix it slow. So back to the issue, when they received complaints from the second level support, they were more like several customers who complained about like slow login yesterday evening or 2 days back, something like that. So this team who had this product with this login had a basic application monitoring in place, which did not support distributed tracing at that point in time. So it was hard to search for particular request among like a sea of requests without having proper distributed tracing in place. But what they had was a system that added trace IDs to the request, and they always logged that trace ID. And they used this to troubleshoot issues. For example, they displayed the ID on the error pages, so the customer can provide this info to first level support, and it was possible for them then to see the life cycle of the whole request, where it failed and why it failed, etc. So they extended the same idea, and they started logging the response time alongside the trace ID in each of their services, so they can get better understanding of how long it took for a particular login to complete. So the idea was then to get alerted when a particular login request took more time than the acceptable threshold. So you could basically do some sort of like pattern matching when the login took like 1 second or something like that. So the problem was the log management solution we had at that time was not sophisticated enough to get alerted on logs. So it was also hard to search for logs spanning for hours or days. So if you go and search like, okay, give me for the last month, all those logins that took more than like 1 second, it would just show a blank page, but rather it was very easy to search for logs when you knew a time frame which was as small as 5 minutes or something like that. So the team came to us with this problem. So the next step was to find a logging solution that was reliable and sophisticated. So until this time, our platform is young. So now we thought, okay, this is the time we have to invest in a proper log management solution. So what do I mean by reliable? So reliable means we wanted some hosted solution, so we didn't have to host it, and that was well maintained and performed well under the load, right? So by sophisticated, what we wanted to have is like, fast search, analytics, and most importantly, monitoring and alerting. So we wanted to find a solution as part of our team with much broader application that could be used by more team than this one team which had actually the issue. So we wanted to make our platform like a bit more mature. In the process, we figured out getting a hosted log management solution is actually complicated, because the reluctance to let third party to process and store logs. Logs are sensitive. They might contain sensitive or personally identifiable data, and long processes to get through the security and legalities. When you're working for a big company or any company, and you are sending like some identifiable data or logs to third party services, you have to have the correct paperwork in place. Or maybe at that point in time, your company doesn't have enough budget to invest in a software as a service solution, or not enough capacity to host and manage an on-premise solution. For example, you could, in theory, like have an elk stack and basically like, you could host it yourself. All of the above are very important and valid reason for any companies, because logs, as I said, are very sensitive. Our goal was never to build a temporary solution. There are services available that help you exactly with this use case, more to do with log monitoring like elk stack or paper trail. A lot of monitoring solutions also have like, log with context and so on. So it's a thing that's available everywhere, but we had to invest in times to get through these problems. So if you're able to overcome these hurdles I just mentioned, you should not have to reinvent the wheel. But in our case, we had to find a good solution for the platform, and we needed some time. So while we were waiting for a proper solution to be in place, we thought, what if we build a solution? So what exactly we wanted for this particular team, right? So we wanted somewhere where we could receive logs from multiple applications. So this team was basically having like multiple microservices and so on. So we needed to be able to receive logs from multiple applications, and we had to store the pattern configuration. So when we knew that a particular app is sending us the log, then we had to look up like what is the pattern that we have to match so we can alert. And we also wanted to know where we have to send this notification to, right? And the process the incoming log of an application against the configuration, like I said, and send alert to the configured channel when a match was found. Right? So putting it in boxes. So ideally, this is what we wanted to build, nothing super complex. So we needed some sort of a broker which would help us to write the configuration with the pattern and the place where, like a webhook URL or a Slack channel URL, where we could send the notification when we found that the pattern matched, and a log monitoring app which will receive basically logs from multiple applications. So in the essence, we wanted to, like how a web server can handle HTTP requests, we wanted to build a server that can handle logs. Simple, right? So so there should be some sort of server that can handle logs. So syslog to the rescue. So what is syslog? So in computing, syslog is a standard for message logging. It allows the separation of concerns, which means like it separates the software that generates the messages. So in this case, it's your application and the system that stores them, and the software that reports and analyzes them. So a sync that could receive potentially all the logs from all the applications on your platform and has the ability to kind of like forward to, let's say in this case, our log monitoring app, which can then analyze each log, match for the patterns, and send the alert. So syslog operates in a client server model. So syslog server listens for the log messages coming from the clients, in this case all the applications that are basically writing the logs to std out. So like HTTP requests have a structure, the syslog also has a structure. So a syslog entry is structured text which contains information about like priority, the host name, when the log happened, the app name, the process ID, and some sort of structured data. And finally, the log message itself, what we log when we say log.info or something like that. So one of the interesting things to mention here is the priority. So we have always known that when we say log.info, then it has a severity level as info. But if you look at the structure, you have a type called priority, but you do not have something that explicitly says severity. So normally how you can identify the severity of the log is by looking at this number and dividing it by 8, and then the reminder becomes the severity, 6 in this case, which is info, and 10 becomes facility, which suggests which particular system gave this information. So it is kind of like native to the system that is ecosystem that is sending this information. So normally 10, I think, means something like security or authorization type of system that is sending this particular message. So in our case, what is really important for us is the app name. So our platform uses unique IDs to identify the application that is deployed. So in the place of app name, we actually got a GUID, which we can then use to basically look up for the pattern, right? So let's now jump into like how we are going to build the solution. But before we go to actually see how we wanted to implement it, so the other thing that we were having in mind, apart from all the things that I mentioned before, we wanted to be sure that what we are building should be robust, and it has to have like low resource footprint, because we don't want to like invest a lot of money on like building huge servers, and then which should have like low maintenance cost, and it should be reliable. So when you hear all of these words together, at that point in time, immediately what popped in our mind was, yeah, we should just ready, steady, and write it in Go. Because knowing the power of Go with respect to robustness and the low resource footprint and the mechanical sympathy of the language itself, it was our obvious choice. And one of the point we discussed before was low maintenance. So what do I mean by low maintenance? Because we really didn't have the capacity to build a complete log management solution, but we wanted to build a very simple solution that kind of like caters to a particular need, right? So we wanted to leverage on the powerful standard library of Go. So we wanted to keep the dependencies bare minimum, so that like later we could build something like Dependabot or sneak into it and keep like updating just the Go version for as long as this product needs to stay, which means until a proper solution is in place. So we didn't want to maintain it for a long time, and we wanted to make our life easier. So this is one of a good reason for basically to for us to also, apart from the performance reasons, we also had to go with this reason to use Go, right? Cool. So here is a sample snippet. So I didn't like put the whole application, how we built it, but rather just to give you a very small idea. And this was our POC code, proof of concept code, just to see if this idea would actually work. And as you can see, it's just few lines of code, and then it worked actually amazingly well. So you can follow the emojis here. So basically what we did was to set up a server, and then we had like this channel handler, which is basically a channel which is listening to the log messages that comes into this server. And here the syslog server would already parse the message and give us a map with all the log parts, and then we would just take the app name, look up for the pattern, and then if a particular application has more patterns configured, then we would just range over it, and then if we found a match, then we basically send the alert. So this is just a snippet for the idea, but our actual solution, we had to develop a stable production ready solution with CI, CD, some testing, and all of those workflow, and to implement it. So we also needed to write a broker that has to store the configuration before an app could use the log monitoring solution, right? So it took us about like 1 to 2 weeks to get everything in place, completely even test drive the whole application, and then we went live. When we announced the general availability of this product on our platform, it was kind of instant hit, and many teams started to use it than we expected. So it's very natural that we saw long processing times under load, and we quickly, so if you remember from the last diagram that I showed you, so this is like the very simple representation of what we wanted to build and what we actually built. So when we saw that, okay, we have long processing times under the load, it was very natural to just add cached, right? So as we found that most of the app did not change the configuration as often, so we had a combination. So we added a multi-level cache. So we had one with the least recently used cache, an in-memory cache within the application itself, and a Redis cache, and then we had our database ultimately. So it took some runs to find out the optimal time for caching based on the usage pattern of the apps and how often they change the configuration values. But once we had this in place, we could really see performance improvement like significantly. I mean, it didn't end there, and we had also out of memory errors. So I think experience of running an application is not complete if you didn't have an out of memory error. So we really made some silly mistakes. So we built a log processing server, right? That's receiving all the logs, and logging processed log is actually a bad idea. So what we were, when we were testing this out, every time we wouldn't find a match, we had just like, okay, I processed the log and I couldn't find a match. So this was something, and we every time we received a log, we logged it also. So when there is like huge load, it's like twice the amount of logs, and it basically like crashed our system. So that's a bad idea. And one thing what I have learned while building this solution is how stingy you have to be when you are actually logging. So when you have a production application, log really meaningful things and don't log everything, because when you have more load on your system or something, then it's not useful when you have just noise and not log actual values. Yeah, so once we fixed that, we still found that there are some more improvements we could do. So one of the examples, so the power of Go lies in its tooling, which is like comes super handy when you really want to optimize for performance. So I will come later like why we wanted to optimize for performance, but so we wrote a couple of benchmark tests for our critical path, and I'm going to just show you one of the benchmarks that we did. So one example was we identified we could improve the marshalling of our configuration. So we ran some benchmark tests and found that if instead of using JSON marshal, when we use JSON encoder with the buffer from the sync pool package, so when we use the sync.pool and with the buffer from that, this made like significant improvement. So if you look at it, the deltas don't seem much, but under the load, this small tweak even helped us to stabilize our application even more. So bonus homework for you, if you want to learn a bit more about like benchmarks, maybe you can read very interesting things about the null hypothesis and what the p-values are and n-values are. When I learned this, it was really was very interesting, and it really gives you a new way on how you would look at your benchmark tests basically. Yeah, so once we did this, we had a pleasant surprise that Go does not support negative look ahead when you have regular expressions to match. So we didn't realize it until some team reported to us that, hey, we are not getting alerted, but we are able to see that a log which could match our pattern. And this is the first time I realized that Go doesn't support negative look ahead. And I'm not sure if they're going to support it in the future, but we had to come up with a small workaround in how to configure the pattern for the alerts. So this was kind of like one of the last feature we added like about a year ago. And with this, we had no additional feature request, and the solution till date is actually running smoothly. And the last update that we did was moving from dep to Go mod. Yeah, things like that. So just minor maintenance things that we are doing, but the application is just running really smoothly. So I will let the numbers speak for Go. This is the numbers from like 2 weeks back. So we are handling at about 177K logs per minute. And while handling this, the average RAM utilization on this constant load is like less than 30 MB. So this is like an average value, but most of the instances are actually using much less resources. So it's kind of like a win for us. And then the last quarter service availability is 99.5. So yeah, coming back to the question, why we even built this, is the login fast now? Yes. So with the help of the alert, the team found the pattern which caused the slow login for some users. And apart from this, some interesting usage patterns also emerged. Some teams use the alerts to monitor their business KPIs. So when we first learned about that, I don't know, I found it really, really interesting that you build a solution for something and people use it for something else, but really like, interesting use cases. And fast forward some months later, we also got another requirement to basically build a log forwarder that forwards the log to third-party service, which has all the functionalities the team would need: analysis, context-based log. So you basically can drill down to the log line when 500 happens and everything. So we had to write a small application that can batch the logs, process it a little bit, like, find out like common patterns like emails or some sort of credit card numbers, or I don't know, whatever, just to make sure that the log sent to third party services doesn't have any sensitive or personally identifiable data. So this solution, last week we handled 3 million logs per minute for about an hour. We just had an alert which said like, okay, there seems to be like a sudden increase or burst of traffic into this syslog server. And about an hour with 0 crashes and no out of memory errors, and we upheld all our SLO. So basically our SLOs is 99.5% of logs are processed and sent to this third-party service within under 1 second, and we were well within our budget. So in the end, all this confidence is because the simplicity of the Go in combination with the powerful tooling that help us to write a robust and very stable application that really requires like little to no attention. I hope also my experience inspires you to try Go if you have not already. Even though we have other solution in place which can totally replace it, people still love the solution because it is really simple, just for one reason, that they can check in the configuration for the pattern and completely automate a lot of stuff, which doesn't require them to have a UI and go enter some things. So sometimes it is not bad to build something when nothing else fits, because it can become useful and it can also give you a lot of learning. Thank you so much.
Thank you very much. That was really, really interesting. I love like following the story along. I just asked on YouTube if there are any questions for you. Maybe you have 5 minutes that we could use if people have questions. Otherwise, as I mentioned earlier, we are all active on the Slack, on the Gopher Slack in the London channel. So I'm sure that if anyone has questions for you, they can post them there. And maybe they can tag you, and so that you know, and you can go there and reply. So I don't see any questions for now. So maybe I'm going to move on. And again, if anyone wants to ask something, I'm sure they can do it on Slack. So let me share my screen again. And okay, so yeah, continue. And I'm gonna share the screen. Cool. Thank you very much again for your talk. And now we're going to move to the next slide, which is next meetup. So next meetup is going to be September 15th. Again, we assume it's going to be online. You can see there in August. We don't know when, to be confirmed, because we still have the idea that it might happen something, but we're still trying to understand, you know, what we could do. And in that case, we will reach out to people via meetup.com or you know, Twitter, and you will know if we do anything in August. Otherwise, 15th of September, again online, and we hope to see you there. As I mentioned, we are active in the hashtag in the London channel on Slack, where a few of us will stay there for some chat after the event, which tries to replace what we used to do after a real, in-person event, going all together to the pub, maybe have some, drinks and talking about Go. We still hope we will be able soon to do that again with you. Yeah, again, thank you to our sponsors, Tig, JFrog, and GoBridge, and everyone. Again, thanks for following us and being with us on YouTube and live stream. Videos will be then also uploaded so that everyone can watch them again afterwards. And again, thank you to our amazing speakers. As I mentioned at the very beginning, to them, it's thanks to speakers that we can host this event, on top of course, the help from our sponsors and our attendees. So with no further ado, I will see you soon, and I'll see you on the London channel. Thank you again. Thanks, everyone. Thanks, Bat. Thanks, Ban. See you soon.